Okay, that new intro is actually pretty darn cool. Just gotta say, that was pretty awesome. It's been a lot of fun playing with Universe Sandbox, and I'm sure everybody else that's been playing with it has pretty much the same feelings, that it's just a fun piece of software to mess around with.
I use it to take out my frustrations on other planets.
Well, you can only get so mad at Jupiter before you go and turn it into a star and supernova the thing.
No, I mean ramming objects into planets.
It does have that ability too. I've yet to do that. I kind of like to supernova things and blow them up, but you know, teach their own.
You two are hostile.
Well, we have been working on an experiment for about 2 weeks now. You know, it takes a little time to get some of the stuff in. And to give a brief overview, since we've been since we've been talking about spectroscopy, Tornado Pelt has been very interested in conducting this experiment. So we're building an apparatus and creating this thing. And
may I divulge what the substance we're spectroscopying is?
We're getting there. So we're using a multitude of different substances, all metals, obviously, be it the way you think about metals or not the way you think about metals. But we are building a contraption that is going to give us a very, very visually attractive fire show. And, well, I've been having a lot of fun. I don't think my neighbors are enjoying it as much as I am because, of course, I'm doing all of this at nighttime. And I'm pretty sure that one neighbor already called the fire department on me, thinking that I was insane and doing something I shouldn't be doing, but he calls the cops on me quite a bit, so I'm okay with that.
Really? Yes. Are you serious, Andy? Does this guy actually call you all the time?
Oh yeah, he's called the cops on me at least 8 times since I moved in here.
Oh, by the way, Andy, have you noticed there's no huffing and puffing this time?
Indeed.
I've commandeered my mother's microphone.
There you go. Well, anyway, so the experiment that we're conducting is part of the spectroscopy that we've been talking about, and burning certain metals so that we can not only watch how awesome it is to, you know, do that, but also to run them through the homemade spectroscope and view their absorption lines and how it is that we can determine different elements on, you know, different stars, different exoplanets, and all that fun stuff. So while it's really fun to sit down and maybe take some strontium nitrate and stir it up into some methanol and light it on fire, it looks really cool, it's really bright, it doesn't make for very good video. So I've taken Tornado Pelt's chemistry and I'm turning it into something a little bit more industrial. So I'm in the process of building a forced air burner that, as opposed to just mixing this with that and lighting it on fire, we're going to have a giant backyard blowtorch.
Ooh! Sounds fun! I wish I could move in with you, Andy. You are actually a very exciting individual.
Well, you know, you got to do something to pass the time, right? Well, might as well be science. So we have and this is Tornado Pelt's recipes with what we should be taking a look at. So obviously I already mentioned the strontium nitrate, and we also have copper sulfate. And Tornado, why don't you go ahead and describe why it is that we're using some of the other elements that we're using, as this is your experiment that I just happen to be building. And remember, keep it family friendly. It's not Friday night, it's Sunday.
Okay, I shall take it from here. Technically, we're using mostly elements from the left side of the periodic table. That's your alkali metals, your alkaline earth metals. Happen to be the basis of most of the metal salts, like sodium chloride. That's table salt for those of you who don't know exactly what that is. Unfortunately, we will not be using homeopathic dihydrogen monoxide, as it is not very conducive to burning. In fact, if I'm correct, dihydrogen monoxide only puts out fires. Unless you electrolyze it first. Then it's very exciting.
Well, you can use certain metals to separate the hydrogen from the oxygen and make some very exciting things happen, but we don't suggest doing that.
For the most part, the cation side of the experiment, because when we burn certain metal salts by mixing them either in flammable or holding them over, did I say flammable gas? I meant methanol. Or holding them over a Bunsen burner and lighting the sucker up, well, you light the atoms in the cation side of the molecule, specifically sodium, strontium, barium, if you really want to get in fun things. You can actually get various colors because the heat excites the atoms and they jump up in energy level, and then the electrons fall down and emit light. They fall down in energy level and emit photons in certain wavelengths. So for lithium and strontium, you can get red light from the fire. For calcium, you might get orange. Carbon will definitely give you orange. Most hydrocarbons do. For sodium, you can get yellow. Copper, barium, boron, you can get green. Or if you're really skilled, you can make blue flames with copper. But that's for skilled pyrotechnicians and probably something we will not be getting. Potassium or mixing certain chemicals together will give you purple flame. Old-fashioned magnesium ribbon will get you a nice white. For the blue color, we're actually making an industrial sort of blowtorch, or at least Andy is. How we get the bright blue flame. Unfortunately, from what I hear, Andy, the original blue flame was kind of
Well, it's just kind of dull, and it's difficult to video and truly capture all of them, which is why I decided let's sit down and make a forced air burning unit so that we can really have some oomph behind the flame, as opposed to just sitting down with a lighter and lighting some methanol on fire. Let's add some forced air and let's really make that bright.
Look at that. You answered. I was going to bring to your attention one of the questions Paranor was asking. Backyard blowtorch? He seemed very interested in that, and you have just given the description. So, nice job.
It is effectively a massive backyard blowtorch, but it's being constructed under very delicate and very careful consideration to the fact that I don't want to get in trouble with anyone. And I also have to find some very thin mesh wire baskets that can actually hold the media in place while it's both being burnt with methanol. So methanol burns extremely clean, and part of its brilliant blue flame that Tornado Pelt was describing is how clean it actually does burn. And
that's called
some of the first tests that I was doing with this, I was actually using ethanol instead of methanol because it's really easy to go down to the store and get ethanol. You have to go to a little bit more work and go to the auto parts store to get methanol. But doing some of it, using ethanol instead of methanol with some of the original trial burns, there's a lot of orange flame that overtakes absolutely everything. It doesn't quite burn as clean as methanol does. And methanol burns so clean and so free of, distorting colors when you're doing experiments like this, that it takes away from the ooh and the awe and the awesome of what it is. And sure, you can still put the spectroscope in front of it and you can look at absorption lines that different metals create, and that's a lot of fun. But sometimes you just kind of want to watch awesome fire.
I can imagine that. Speaking of which, one of my memories of fires was when there was a fire over at someone else's house, and this is relating into the chemistry experiment that we're getting ready to do. Well, more specifically, Andy's doing it. I'm just suggesting the stuff to use. In the fire, I ended up seeing when one of the firemen was actually spraying the fire down, I actually saw bits of white fire in with the rest of the thing. Not just regular white fire. We're not talking the white hot stuff. We're actually talking white as in magnesium white. And this whole experiment that me and Andy are doing, like I said, Andy's just building it. I'm suggesting the chemicals to use. It was all based on a 9th grade science fair project, which was actually really... Basically, me and my science teacher back then, Mr. Kitchens, we had various chemicals in the chemistry cabinet, and we decided to see, what happens if we basically light this metal salt on fire? So we poured the stuff into methanol, stirred it around in the beaker, and then lit it on fire. And for lithium, we got a nice red flame. For calcium, we actually got sort of an orange-yellow, and we actually did use copper for a nice green. Then I got the bright idea to say, let's see what happens if we mix all these chemicals that we use all together in the same beaker, stir them all in methanol, and light that on fire. We got an epic rainbow.
I was doing something of the sort on Friday evening, and it didn't quite work out as well as your experiment did, but having it sit out, so I effectively the exact same thing, only again, I used ethanol as opposed to methanol, and mixed so I got strontium nitrate, I have potassium, I have sodium chloride. Obviously, everybody has sodium chloride. You'd kind of die if you didn't have it. I have my copper sulfate and I sat down, I mixed them all together with, my ethanol is Everclear, because that's the store I was talking about going to. Put it all on a cookie sheet after mixing it all up, lit it on fire, and this is how I got the cops called on me again, because there was a fire in my front yard. But I didn't quite have the results that you're describing. The results I got was primarily the copper sulfate actually outdid everything else, and it was a blinding green flame on a cookie sheet in my front yard. And I think my neighbor thought it was fireworks, and that's why he called the police, because no fireworks, well, whatever. It happens. But the copper sulfate actually it was the most brilliant of the light being produced. Like I've said in the past, I'm not a chemist, I'm not a physicist, I'm not a lot of things. I am an engineer and I like tinkering and building stuff, but I'm not entirely sure why it is that the copper sulfate took over and burned more brilliantly than everything else. But it was pretty darn cool because it was getting a good foot-tall flame of bright green. And that was just awesome.
Well, there are several reasons I might be able to state. Number one is you might have added too much copper to the mix. Number two is that I've noticed that green and blue wavelengths always seem to outdo red. Like, I've actually done this experiment accidentally with a color-changing LED lamp, and I basically switched it to red, switched it to green, and switched it to blue, and the red was definitely overpowered by the green and the blue. So it could be either the wavelength of light or how much copper sulfate you added.
Well, I do have more copper. The copper sulfate that I got was the cheapest, so I've been using it pretty liberally.
That might explain it then.
Well, either way, so this is obviously a very fun experiment that's taking a couple of weeks to sit down and build in full and get everything working right and running properly. It's going to be a lot of fun once we actually have the whole thing put together and running the way that it should. This also happens to be Thanksgiving week, and while that's going on, I should just put this out there right now. Next week, we're not going to have a Sunday Science Show. I have family coming in for Thanksgiving, and most of my family is on the East Coast. I live in Colorado, so we don't get to see each other very much, and Thanksgiving is one of those times during the year where we actually get to see each other, so it's a lot of fun to catch up with family and spend time with each other. So next week, unfortunately, there will not be a Sunday Science Show, but this will also help give us time to make sure that this experiment is up and running and an absolute blast for the week after that. And just wanted to toss that out there, let everyone know right now. Thanksgiving kind of takes precedence sometimes.
So I take it we'll be having a Monday Science then?
I don't know if we'll have a Monday Science Show. Like I say, I get to see my family maybe once every other year, and we're a big family. I have 7 uncles and 2 aunts. And that's just my mom's side. So we have a big family, and I don't get to see any of them. And when you have some cousins that still haven't even graduated high school yet, and other cousins that work in the patent office, it takes a long time to catch up. So we might not have a show at all next week. I'm not 100% sure. Just thought I would toss that out there.
I can wait.
And I see what you did there, Andy. When you come back for the next show, have a blast. I see what you did there. Have a blast.
Yeah. I used to have this word game that I absolutely loved playing with my wife, and it is so much. It's kind of like a fun with words, where you get to pick an adverb or an adjective once a week, and whoever gets to use them in the most intricate ways, they win word of the week. And every now and then you just have to sneak in a word like that. It's not an intricate word. It's not going to help you build your linguistic skills by any means. It's not going to help you learn the English language any better, but it sure is a fun game to just constantly have one of those brain teasers sitting around that you actively use.
Agreed. That is a good thing.
I have my own brain teasers, Rubik's Cubes especially, but at this point they're no longer brain teasers. They're more like, hey, this is what I do when I'm bored.
That's
so a little bit more of an. Oh, sorry, Stray.
Oh,
Go ahead.
I was just gonna say, that That sounds like something we should broadcast if you're like Super Cube Dude. one of these days during the week or something. Anyway, go ahead. Sorry to go off on a tangent.
Oh no, this whole show's kind of a tangent. There's no going off on one. It's science. That's how we excel. That's how we progress. That's how we learn and discover, is by recognizing the tangents that we need to go and run with them.
I'm going to quote scripture here. Science rules.
Good with that.
Well,
all right. I hope you've been doing a fair amount of photography with your backyard blowtorching so far.
I have been doing a decent amount. The Backyard Science G+ page, I need to adjust the title of the last one that I posted there, because had the worst. It wasn't even autocorrect. It was just me accepting a word that is used more than absorption.
I saw it.
Yeah,
Right.
that has to be the worst grammatic error I have ever made in my life.
That was.
And I do apologize
that
for.
Was just bad luck. That's
that was terrible.
Indeed.
But yeah, need to fix that. But yeah, I've definitely been having a lot of fun with homemade spectrometer. I like calling it a spectroscope because realistically, it's a telescope with a prism. It's really not a full-blown spectrometer. I'm doing the best with having a camera sitting behind the telescope and the camera tripod with a prism on it and doing everything that I can, but it's not a spectrometer. I've worked with spectrometers at the USGS, and I've helped people build, calibration tools for them and adjust them to be able to work with what their specific scientific needs are. And what I have is a telescope, a wide-angle camera lens, and a prism. And sure, that's kind of where science starts. And this is what I love about doing science experiments at home, is you can go back to where this tool actually originated, how it first was incarnated, and you can reproduce it, and you can see for yourself, oh my gosh, this is, I can sit down and I can grind a mirror, and I can put it in a tube, and I can put a little 45-degree mirror inside that tube, and I can see what Newton saw. It's not some, you have to have this computer with this CPU and this graphics card in order for the software to work. No, you go out and you do it. It's
oddly therapeutic.
Naked science, I guess. It's so much fun to take a look at some of the older experiments that so much technology has been built around. And I know a lot of people this day and age kind of question, well, how in the world did anyone go from that to that? And photography is one of the biggest ones with that, because now everybody has a digital camera. Everything's digital, and no one has to sit down and actually develop film. So when you don't sit down and you don't do those science experiments, when you don't go back to the historical end and put in the time and effort to actually go, wow, this is freaking cool. And going back to a silver plate that has a chemical smear on it, that if you hit it with light for a certain amount of time, it's going to reproduce that image. Mirrored, of course, but it's so much fun to sit down and actually do that. And I think a lot of people have actually lost understanding how it is that a lot of this stuff works, because when I was in high school, I was able to go in and take a photography class, and I could sit down and I could look at film, I could touch film, I could see film, I could put it in a camera, I could learn how the optics worked, why it is that we're able to have optics of that sort this day and age. I could take that picture, I could take that film and put it in a chemical bath, and I could develop an image onto a piece of paper. It was amazing. Now you take your phone out of your pocket and snap a picture and
click.
You print an image. Well, that's really awesome technology, and I'm glad that we have it, and I'm really glad that, you know, NASA helped develop this technology for us to have. It's great, but it's that fundamental understanding that it's so important to have the fundamental understanding and to really go back in time sometimes and build these experiments. Like I said earlier before the show started, while we were chatting amongst one another, I actually just had to sit down and re-upload a Cavendish mechanism once again. I've built this thing in my basement probably 3 times now. And every single time I have the exact same result, because gravity is attracting matter. So I have a torsion beam that's suspended from a 24 gauge single filament copper wire. I know what the torsional resistance of that copper wire is, and I can watch it back and forth, granted, it's an incredibly boring process to watch it, and I'm kind of weird for the fact that I have actually watched it for hours on end, but
does it make
that's an experiment from the 1800s. And sometimes you just have to go back in time, and you have to build these experiments that other people already did. Because it's so easy to get caught up in all of the technology, all of the instant gratification of the 21st century. It's always at your fingertips. It's right there. Sitting down and watching a torsion beam come to rest for 3 hours so that you can place the weights necessary to show objects falling sideways due to gravity. It takes a long time. It's a full day of the most boring thing imaginable. But then you see it come together, and you see it come to life, and it's science at your fingertips, and it's the basis of, I can do more science than that. Somebody else already did this, and I want to check it. I want to see if it holds. I want to see if it's true to its nature, and it is every single time. That's why it's part of the scientific methodology, is because you can do it, you can repeat it, you can go in, and it doesn't matter when you put it together, it doesn't matter when you build it, you'll wind up with the same results. It's repeatable, and it's awesome.
Most definitely.
Amen to that.
And it's still, and as I've said to you before, I have on a few occasions, even though you know you do everything right, and you know exactly what it's going to do, there's still that moment of excitement when the experiment you're performing does what you were expecting it does what you were expecting it to do. That's the big moment.
Right? There's such a cliffhanger with it sometimes, where you're like, is it really going to work again? Oh, yep, it worked again. That was awesome. It's not sitting down and dropping something and going, yep, gravity's still there. No, you can design and produce an experiment, and you can make a hypothesis based around, how am I going to do it this time? If I use a 24 gauge wire to suspend the torsion balance, how is it going to differ from if I use a 36 gauge wire? Well, I tried the 36 gauge wire, and it snapped. It didn't have...
You had to pick some things up.
It didn't have the tensile strength necessary to actually support the mechanism, but that's still one of those things. What is going to happen when I do this? It might break, it might fail, it might succeed. But every single time that you do it, you do have that kind of butterflies in your stomach of, is it going to do the same thing it did last time? Well, if it's repeatable, it will.
Indeed. And with that particular experiment, the only people that claim that the experiment never happened or didn't happen as described or just didn't work and hasn't been reproduced, and there's a lot of people making that assertion, have never tried it. They've never tried it. And really, it takes time to let it settle and to carefully not producing wind, make sure all the weights are in place. But
it is very difficult to set up
but
an at-home Cavendish mechanism. I mean,
indeed, it's time,
you know, when you're dealing with something you might have two of that are of equal weight and weight distribution, so I can't have a 25-pound weight and a stack of weights that equal 25 pounds. Their overall mass is the same, but you want everything to be as close to equilibrium as possible. So you're going to want two things of identical size and mass. You know, I don't want 25 pounds of sugar cubes sitting next to a block of iron. It's aesthetically unpleasing, and it does actually create different effects because you will wind up with actual wind resistance issues. So you want things that are symmetrical and equal in mass. I use bowling balls. I happen to have a 16-pound bowling ball that's drilled for a right hand, a 16-pound bowling ball drilled for a left hand, and that's just because I'm ambidextrous and I bowl with both right and left.
Hey, Andy.
Whatever.
Not at the same time, I hope. Go ahead.
Has any flurfer ever said, "Oh, it's all fake, you're just a shill," when you do
all
this
of them.
experiment?
Actually, half the reason why I rebuilt this was because our friend Sean had brought it up to Globebusters with my in-basement Cavendish mechanism. And they tried saying it's all bullshit because I didn't film the thing coming to rest prior to placing the weights where the weights need to be. So I built it again, and I went through a 4 gig and an 8 gig memory card just trying to record how long it takes for it to get to rest. And I can... if you ever build a Cavendish mechanism, don't bother waiting for it to come to rest. Just get the thing suspended from the ceiling and come back the next day. Because I spent 6 hours watching this thing.
Did the Globebusters call bull crud on you after that?
They always will. That's what they do.
Yeah, there's always one more condition. It's
yeah.
And eventually it devolves into the silly stuff like no, we have to see a picture of your cat or we don't believe it. It does get to that level of silly. And the only people who doubt it, this particular experiment, are the ones who have not tried it, and it's not that big a deal to do.
It's a really easy experiment to run, and
I do not have the patience.
Well, the fun part with this is, with building a Cavendish mechanism, is you can put something together very easily, allow everything to come to rest, and then as soon as you have gravity attracting a smaller body towards it, and then the torsional resistance of the wire retracting, and it just keeps going back and forth and back and forth and back, you can just let it sit there for days and days and days. You can leave it alone for a week and completely forget about it. Come back a week later and take a look. Yep, still doing the same thing.
Basically,
you don't actually have to like actively be a part of the experiment. You build the mechanism, you suspend it from a fixed point, and then you just watch gravity. It's so much fun. I think everyone should build a Cavendish mechanism at least once in their life. It's so much fun.
Indeed.
Yeah,
And,
that would disprove the whole gravity document made by the FEA.
yeah, and I could see why those who've never tried the experiment or witnessed it or seen someone else do it live might be able to cook up some doubts, because it does sound kind of silly. If you're thinking, oh, everything falls down, oh, nothing, how could it work sideways? I could see where the people who have no experience with the actual experiment and a healthy head full of unjustified doubts uh, might find it hard to believe. But there's a cure for that. Build the damn thing.
Indeed, I can see why as well. I mean, it is counterintuitive to the way you would think. I mean, something falling sideways. It's hard to think about something falling if it's not going towards the Earth. You know, so falling sideways it's counterintuitive in your general thought process to even consider that a possibility, but it is an actual possibility. And then, like, as so many flurfers have said in the past, how in the world is gravity strong enough to hold water on the ground, but not strong enough to hold a bird down? Well, when you sit down and you actually build one of these mechanisms and you watch it and you witness it, you can actually start to recognize the fact that for every action, there's an equal and opposite reaction, and that is not just a statement. It's happening in front of my eyes, because this weight is being gravitationally attracted to this larger weight, and the torsional resistance of this copper cable is reacting to it and forcing it to move back to a state of rest. It always wants to be at its lowest energy potential, and that's what it's trying to do. The copper wire doesn't want to put energy out. It doesn't want to expel energy. It wants to be at its lowest energy point all the time. So as soon as it has enough resistance, it pulls everything back to where it wants to be. It's material science, it's physics, and it's live science right in front of your face. It's just really slow and boring. But it's real.
Indeed. Well, that is yeah, like that is something that those who doubt should just give it a try. It's not even an expensive experiment. And
no, it's not. I mean, like I say, the one that I've built, and I've set the thing up a couple of different times, it always yields the same results. It's a meter stick, 2 bowling balls, 2 1-ounce iron weights that are from a lapidary machine that I use for grinding mirrors, and a bit of copper wire. I mean, you don't want to use braided or stranded wire. You do want to use single filament. So grab some magnet wire. It's not exactly expensive. Magnet wire is actually really cheap. And then you can test the different gauges, and you can sit down and go, what is the, look up in a mechanical engineering handbook, what is the torsional resistance of this metal? You don't have to use copper. I just use it because it's readily available, and that's the way that the original Cavendish mechanism was produced, so I follow in its footsteps that way. But if you know the torsional resistance of the wire you're using, you'll be able to maybe even do the experiment with multiple different filaments and see different results. And while you're measuring gravity with a Cavendish mechanism, you're also measuring the torsional resistance of whatever metal filament it is that you're using. So you're doing a couple of different experiments at the same time, and you can get the gravitational constant out of it if you already know the torsional resistance of a wire, or you can measure the torsional resistance of a metal strand just by doing the experiment because you know the gravitational constant.
Sorry, I kind of
so
zoned
much
out
fun.
there. Most of that stuff just went whing over my head. I mean, I know a lot of science, but there's even some stuff that I will admit I do not understand. However, I will not say because even though I don't understand it, that doesn't make it fake.
Hmm.
I'm not that idiotic.
Let's see. This is why often engineers and scientists should be paired with a machinist, because
Indeed.
there are different areas of knowledge, and none have more value than any of the others, and it is difficult for one person to have all the knowledge necessary to understand everything. Like,
although I would like to quote scripture, none of us are as smart as all of us.
Oh, that's pretty good. That is a good one.
That is a good one. And I absolutely agree. There are things that the machinist knows that the engineer doesn't, and it's that way in all walks of life. There's always going to be the thing that the carpenter knows that the architect doesn't know. There's going to be things the iron worker knows that the structural engineer doesn't know. There's going to be things that the horticulturalist knows that the botanist doesn't know. It's full tilt where you have to have both ends to be able to really understand, and you need multiple people to work both ends. You can't have just one person working all of it and somehow it makes sense. Hence why, Tornado Pelt, we're doing this experiment together. You know more about the chemistry than I do. I know how to build the awesome thing that's not going to explode, but hopefully burn. Cool stuff. Really bright. I have that equipment available. You have a knowledge set that I do not.
And you can thank my Asperger's syndrome for that. I have told Sidetrack that is now not able to be publicly stated.
Well, the sharing of knowledge like that, and the building upon the works of others. I mean, that's the only way we got to where we are now.
Unfortunately, there are people like the two idiots whose comments or whose comment words stuff I have posted in the chat here, not in the public chat, because everyone would facepalm or head desk repeatedly, which proves that because they don't understand it, therefore it's fake to them, but we understand it and we know how it works.
Well, I just realized I have not seen any of the public chat whatsoever.
Oh, if you'd like,
I almost forgot that this was actually live right now. I completely forgot about the chat.
Well, here's the link for the pop out if you want it. I'll throw it in the thing here. Yeah, I was just gonna say. Here we go. There you go. There's the link if you want to run the just the pop out window, so that you can see it. Anyway, yeah, what I was gonna say is that the whole building upon knowledge of others, and working in concert with others. That was it Neil deGrasse Tyson? Who was the one that came out with what makes humans different from all other animals? He said there are animals. There are other animals that use tools, and there is evidence that there are other animals that communicate and tell stories, but we're the only species. We're the only tool builders that tell stories. So we're allowed, so we can share knowledge and build better tools, and then continue the process. The whole, and it's not even the folks that don't understand things, but the folks that if I don't do it myself, space can't be real if I can't go there myself. That's what you run into. That I have to see it with my own eyes, otherwise it's fake.
Right.
And that's why only the really smart kids get to go into space.
If we adhered to that, science would not have progressed, or if it did, it would be much much. Well, no, it wouldn't have, because everybody would be starting at ground zero. So
Yeah, it'd be very bleak.
indeed. Alrighty.
We would basically have.
So
to
I do believe that there's something involving a tremendous amount of electricity that somebody else might be doing an experiment with.
Oh, indeed. Yeah, and this is not a. We're not going to restate Son of Van de Graaff, which is now fully operational with an 11-inch sphere and.
This is a new Zappity Zap.
And high speed motor. I'm calling it a high speed motor. It's actually a faux Dremel from Harbor Freight. But it's not going to be more. It's not going to be more Van de Graaff. Relax. So,
when we were talking earlier, I've been really interested. I have a. When my dad passed away, I had to move my shop out of his garage and into my garage, which was not large enough to fit everything. So I had to outsource I had to get rid of a lot of stuff. But one of the things that I did take away was about 300 feet of number 2 copper. I've been trying to decide, should I sit down and do something like what you're doing, or should I build another contraption that, has the ability to melt metal based on magnetic resonance?
Turn the stuff into ingots.
I would
Then you'll be able to sell them.
I would go with that one. But that's shit. I'll tell you what else you have. If you got that much copper is getting more expensive by the day. You might want
no, I'm not getting rid of it. I'm building something out of it.
and save it for retirement, because maybe you can sell it, and by that time bring in a couple $100,000. I know this because I know this because I just bought a spool of 34 gauge for $50. Like, but it's magnet wire. No, $50.
Right. Magnet wire is insanely expensive all of a sudden, and I don't know why.
Yeah, and it's I know copper's been appreciating, and it's getting kind of expensive, but the amount of material, it's like jewelry. You're not paying for the weight of the gold. You're paying for fanciness. Anyway, you asked me. You asked me what the hell I'm building, and I've talked about everything but that. Okay.
It's okay. We all go on tangents here on this show. That's what Sunday Science is all about. Discovering new fields of knowledge and maybe ticking off some flurfers at the exact same time.
Indeed. Anyway, I was just browsing around the web and just looking at various stuff and things, and I came across a circuit for not really a Tesla coil. We'll call it a pseudo Tesla coil. Here, I'll show you the circuit I came across here. If I have it up. Yeah, there it is. There you go. You should be able to see that. I looked at the circuit, and it was labeled Tesla coil, which it isn't. And that's when I first glanced at it. It was the primary and the secondary coils, which in this is L1 and L2. I noticed it's just a coil.
Hey, whoa! They're not Lagrangian points.
They're both just coils, and there's no capacitance, so they're not resonant. In a Tesla coil, it's a complicated thing to build. Not that it's electronic. The electronics is not complicated. drawing out the schematic of how you're going to do it is not complicated. What's complicated is you need capacitance on each coil so that they can become resonant.
Yeah.
That was the whole Tesla thing. Tesla's main thing was he understood resonance like nobody else. Well, there are a bunch of other wild claims about Mr. Tesla, but the real one is he was the wizard with resonance. In the Tesla coil, the circuit would have to have, L2, which is the secondary, the high voltage coil, would have to have a capacitor that could tolerate ridiculously high voltages, because that's what's produced on the secondary. And you need a coil and a capacitor to make a resonant circuit. I mean, there are other ways, but in a Tesla coil, that's what you would have. And you could accomplish that with a ridiculously expensive capacitor that you buy online, or you can make a bunch of Leyden jars, and it's a very complicated thing. So I looked at this and said, what the hell? No, that's not a Tesla coil, and it isn't. But they cheated, and they cheated in an ingenious way, which I like. Off the base of the secondary coil, which is the one that produces the high voltage, very near ground, there's that wire that runs off of the bottom of the coil essentially back to the base of the transistor that does the switching to give it the high frequency. What that's doing, and it's kind of an ingenious way to do it, is it's giving feedback to the transistor 180 degrees out of phase, which causes the whole circuit to oscillate at the resonant frequency of just the secondary coil without having the secondary coil be a resonant circuit. And just the cleverness of coming up with a circuit of that sort amused the hell out of me. So I spent the earlier part of the day printing out in the 3D printer a nice coil form and a nice base for it, and I just like to see this little thing work because I appreciate the simple elegance of the circuit. No Leyden jars, no low value, high voltage, extremely expensive capacitors to explode, and they do.
Oh yeah.
Yeah, it's best to be in another room when a high voltage cap goes. But anyway, so this is a project. The only thing that's going to take some time is winding the coil for the secondary. It's going to be about 1,500 turns on the coil, and that takes a little while to do. Could do.
Did you build anything like a jig that you can hook up a cordless drill to assist in?
See, you can't really do it with a drill. If I was just winding a regular transformer where there was no question of resonance or anything like that, I would do exactly that. Problem is with the extremely fine gauge wires that I want to use for the output coil, it has to be what they would call close wound. Close wound means every turn has to be just bumped right up against the previous wind. And no spacing, no crossing over, nothing like that. And it's too easy to, when you're doing it with a drill, it's too easy to hop a few turns and then your coil gets...
Good point.
Yeah. Now, there are ways to do it with a lathe. Just like you change the gears to cut threads, you can change them some more so that the movement per revolution just happens to be the diameter of the wire, and you can let it go and do the whole thing in, you do the first couple of winds at low speed and then swap the belts. Oh, I'm showing my age. I have a lathe that does not just have a lever to change speeds.
Well,
you actually have
of course you have to change. You step pulleys, belts. This is just how this stuff works. It has nothing to do with age.
Indeed. But, weren't we
I mean, sure, they're youngins that are sitting down with a computer telling a machine what to do, but I'll still take step pulleys and gears over a computer telling me how in the world I need to do this any day.
I would tend to agree. But what was the lathe we were looking at a few weeks ago?
Oh, that one at the telescope focuser.
Yes, indeed.
Company. I think that was badass.
Yes, indeed. I would almost guarantee that there's no swapping of belts on the pulleys.
Yeah, but that's also not a machine that you can like walk out into your garage and turn the heater on and make stuff on. You better have a factory, because that's probably $100,000 tool.
Exactly, and actually, even with the newest, more computerized lathes, in a lot of machine shops where there's repetitive work going on, occasionally it's not sit down, CAD CAM, let's just tell the computer how to do it. Occasionally they will have an actual long-time machinist make the first part while the computer watches them and records the positions. And for sensitive work, I'm told, I cannot verify this, for sensitive work, I'm told that's still the preferred method. So,
well, there is a reason why with what I do for a living, when we sit down and say I'm teaching a robotic arm how to do this job, it's because I basically am teaching the robotic arm. I'm not sitting down with CAD CAM software and going, you need to move along this coordinate system. No, I'm sitting down and having an actual master craftsman go, this is how to sand the spine of this piece of metal.
Oh.
Now teach the robot how to do it. Okay, well, we teach robots how to work in manufacturing. We don't necessarily program them the same way you would a CNC machine. So,
and you just reminded me of something with your mentioning of the robotic arm. And I don't think in all the talks we've had about the recent NASA social thing, this one slipped my mind entirely. Remember, we were talking about the satellite servicing, which is another satellite that both refuels and repairs dead satellites that were never meant to be refueled or repaired. It has a robotic arm with a multi-tool at the end for cutters to cut through the blanket, radiation proofs them, and various tools anyway. The thing about that just came back to memory because of you mentioning the robotic arm is the robotic arm on the thing is obviously, since it's meant to operate in space, the actual item cannot operate on Earth in Earth's gravity. So they have an analog of it, which is a commercially available robotic arm that's used to assemble things, and they wrote some middleware software in between so that it's controlled with the same command set that the one on the satellite servicing unit would. And what I found hilarious was when they told us that the model that they use for this, the ground testing to make sure all their programming is correct, is the exact model that IKEA uses to make the furniture you go to buy. I found that just amazing. Okay.
It probably happens more times than a lot of people realize.
Anyway, Andy?
Yes, Tornado.
Like I said, I'm not a machinist. I have no idea how to operate a lathe. The only thing I really know how to operate that's even manufacturer's sort of thing is a belt sand. Like one of those sanding wheels and such.
Yeah.
And I just use that to make curved shapes. That's my minimum expertise on that.
Well, even with that, keep the fingers back.
Right, keep the fingers back, and if you're interested about learning, manufacturing equipment or something to that effect, how to make stuff, I'm always willing to help people out learn new stuff. And I do have a weird niche job that has given me the opportunity to be able to, well, make stuff that crashed onto the surface of, well, at least I hope it crashed onto the surface of Mars. It just kind of disappeared because some dumbass forgot to convert. Metroid. Anywho.
Again?
I made stuff that's gone to a lot of different places, and I made some really cool stuff throughout my years. So if anyone's interested in just, hey,
hats off to you, Andy.
Make stuff.
Hats off to you.
I'm willing to help teach anybody how to make stuff that I might be able to. If I have that knowledge base, I'm willing to share it.
Okay, Andy. You don't have to. It's the family-friendly show. You don't have to say it out loud. But do you have the public chat up?
Yes.
Look now. Look 4 up from the bottom.
Oh God!
All right. Okay, everybody's seen it. We don't need to say it. Okay, good. All right. Anyway,
I'm going to stick my fingers and go in my ears and go la 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 la.
Yeah, there's.
Oh, speaking of lathes, Andy, I mentioned Harbor Freight for the faux Dremel for the other project, the Fremel.
Yeah, the Fremel.
You know what else they had, which I didn't see this before. A tiny metal lathe. It's about 3 feet across for like $200. It was. I mean, I don't need it, but it was just too cute.
Oh, come on, you're on the East Coast. There has to be 10 times more machinery auctions. I know you can find a South Bend. There's no reason to cut yourself short.
Oh, still, but I mean, it was tiny. It's like I wish I could justify this, but I can't go strolling into the house with this and park it next to the other one.
Well, right. I bet if you go to like machineryauctions.com or any. I mean, there are several different auction houses that I look through. I guarantee you could probably pick up a South Bend manual lathe for $10.
That would be kind of cool. You know what? Jules got a lathe. You know what I really been looking for? Bridgeport. Anyway, all right.
Yeah.
Problem is, the problem is any Bridgeport you find that's not going to cost $50,000 is beat. It's just not accurate anymore.
You're gonna have to take the thing apart and rebuild the whole thing.
For which you will need what? A second Bridgeport.
Yeah.
Anyway, hey, look at the time. We have used up an hour already. Oh my.
Oh wow. Okay, well, I do actually I should probably get back to preparing my house for Thanksgiving this week. Like I mentioned earlier, I generally don't host Thanksgiving, but I am this year, so I have a lot of work to do to get dog fur out of places that I didn't even realize a dog's fur could get into, like couch cushion corners and all that stuff. So,
Andy?
Yes, Tornado.
I must inform you that I probably will not be attending December 3rd's Sunday Science or December 1st Friday night movie night because I'm going to be in the process of moving during those dates.
Huh.
I'm just so fair warning.
Duly noted.
Okay, well, I hope you have an easy move, and we'll have you back on the show once everything's back in place.
I'm going to be having a dog on the floor and probably 2 cats in my lap. You call that an easy move?
Well, it's been my experience.
It could be worse.
It's been my experience. All moves suck.
Yeah, moving just is terrible. There's no way out, no other way around it. But we are pretty much running out the clock here, and I do have a lot of work I still have to get back to with the old homesteads, so...
Oh, and by the way, have fun getting that backyard blowtorch to be fully operational. Let's see how bright we can get that red flame to go.
I think it's going to be a lot of fun. I think we're getting pretty close.
And to the chat, I would like to say, Disco Inferno, burn baby burn.
Okay.
Alrighty. I think that's about it for Science Sunday this evening, and it's, well, I'd say bring on the pug, but that's not this show.
That's not this show. We'll just do here we go. We'll just do your traditional ending.
That'll work.
And by the way, Andy, hats off to you for designing all of that awesome space stuff that gets to other planets. I have to say, you are one of the highest nerds in my book.
Quite an honor.
Thank you.
Quite an honor there. That's quite an honor, Andy. All right.
Indeed.
Well, here comes Andy's traditional closing. And thanks, guys. Great as usual. Had a good time.
And hey, this time no breathing in the mic.
Night all.
Although you have picked up some clattering sounds, that was my Easy Cheese container hitting the ground.
Gotcha. Night all.
All right. Have a good night, everybody.
Bye, everybody!